Very good morning to everyone and welcome to this session of MDCAD. Today we are going to discuss or rather continue the discussion that we have left in previous session, and we were discussing about interpenetration of solids. We have discussed why it is necessary to learn about interpenetration, how it is used in mechanical engineering design, product design, and we have seen two examples related to it. So let us start with the session. Let me share the screen with you. Okay, now I hope the screen is visible to you. Now, in previous lectures, we have discussed many things regarding cylinder. As you can see, there was a cylinder and cylinder was penetrating, and we have seen how we can denote the curves. Now in this lecture, we will do 2 or 3 examples. The first one is a cylinder which is standing on horizontal plane and a square prism penetrating through it. Now let us see what does it tells. So the problem is a cylinder with 50 millimeter diameter and 70 millimeter axis or height, okay, is completely penetrated by a square prism of 20 millimeter size and 70 millimeter axis horizontally. Both the axes intersect and bisect each other. All faces of prisms are equally inclined to horizontal plane. Draw the projections showing the curves of intersection. So let us see. This is the end result that we are going to find. So basically what we have a cylinder, as you can see here. This is the cylinder of 50 mm diameter and height is about 70 mm. So we have to draw its front view, top view and side view. Again, we have a prism. Now you know about prism. It is a square prism having 4 sides or faces, we can call 1, 2, 3 and 4. So square prism has to be penetrated. And what is the condition? It is horizontally penetrated. Also, both axes, means the axis of cylinder and the axis of prism, intersect and bisect. Intersect means they are going to cross each other at a particular point, and where? At a midpoint. Why? Because it is saying bisect. Bisect means we have to cut through the middle part. Also, another condition is there. It says all faces of prism are equally inclined to horizontal plane. So if this is the horizontal plane, as you can see over here in this diagram, you can see these faces of this prism are not parallel but are inclined to this particular plane. So this is the end result we have to find, and this curve of intersection is to be drawn by using various drawing tools. So let us start. First we have to draw the horizontal plane x, y. Draw the top view of cylinder. How much is the cylinder diameter? It is 50 mm. So we have drawn a circle of 50 mm, because when you see from the top to this particular scene, we get this circular part of cylinder. Then we can have 4 parts to get the end points. 1, 2, 3, 4, and then we have to project this like this, and we get these points 1, 2 and 4, 3. Just we have projected, and the height is given, which is 70 mm. Okay, so height is total 70 mm. So this completes our front view and top view. Now we have to draw the side view. So we have two methods, by using a compass or by using a 45-degree line. So we are going with next method, that is 45-degree line. We have drawn this and we are going to make the projections first, second, then we have to project this line to the horizontal plane like this, this is the center one, and this one. Then we complete the side view, but it is not yet completed because we have to draw the prism also. So what is the condition? The condition is that we are going to have bisection at the point of intersection. So we need to draw the axis, and we can give the names. 4 comes here, 4 dash dash. So this is very important. If you are going to name, say 1 2 3 4 in one view, then in next view that you are drawing, you should draw or you should write 1 dash, 2 dash, 4 dash, 3 dash, like that. And in next view, next to this view, we have to mention it as 1 double dash, 2 double dash, 3 double dash, 4 double dash. So you will get to know exactly which point is coming at what place. Okay, then we have to draw this particular thing, that is prism. So this is a square, and the condition is these sides 1 2 3 and 4, all of them are inclined to this xy. I hope you are getting it. Okay, parallel जर सांगितलं असतं तर आपल्याला हा प्रिझम हॉरिझॉन्टल असा काढावा लागला असता, right? But they are saying it is inclined, so we have to draw like this only. Okay, so we have drawn this. Now name this as A double dash, B double dash, C double dash, D double dash. Now why double dash here? Because this view should have same notations. So A, B, C, D is the points which is to be given in this particular view. Okay, so we have named this A, B, C, D with double dash. Then we are going to project these lines, points A, B and D, C. Now we know the length of this particular prism. It is 70 mm. So by taking 70 mm, we are going to have this particular drawing like this. Okay, now what happens? Since, see here, this part, this line is crossing through here. Okay, then we have to draw it like a dash line. Similarly with the bottom line, we have to draw it like a dash line. Then project again this in the bottom section like this, and complete the view by taking the projections like this. Similarly, we are going to have these dash lines. Okay, now we have to take these points where the intersection is actually happening. 1 2. Okay, this is the point of intersection at the bottom. Here you can see here. Okay, now we have got these points A dash, B dash, D dash and C dash. Why A dash and C dash are coming here? Because A comes here and C comes here. Also this line is going to come here, so A and C. B and D are on one line, so we have to draw this on one line, B and D. Similarly to the left side, we can get A dash, B dash, C dash and D dash. Now just complete the lines or curves. This is the intersection that we are going to get for cylinder which is standing on horizontal plane and a square prism which is penetrating through it. Okay, this is the case. Now the next problem, in this we have a cylinder standing as usual, and we have a cone. Now you know the cone, how cone looks like. So this is the basic thing, how it looks like. A cone is penetrating through the cylinder. So cylinder is standing. Okay, now let us see what are the given points. A cylinder of 80 millimeter diameter. So we have to draw the 80 millimeter diameter top view, and the height or axis is of 100 mm. So the length or height has been given as 100 mm. And what is the condition given? It is completely penetrated by a cone. Completely penetrated by a cone. This is the cone of 80 mm diameter. It is also have the same diameter, and the axis is 120 mm, and it is penetrating horizontally. Both the axes intersect and bisect as usual, as in the previous case. What are they saying? They are saying we have to bisect. So from the middle point, we have to take the axis. Now draw the projections showing curves of intersection. Let us draw the horizontal plane XY. Draw the top view of this cylinder that is having 80 mm diameter. Next is to draw the front view of this cylinder. Like we get a rectangle, we have drawn having a 100 mm axis. Then this is the center point axis, and we have to draw this particular cone. Okay, now the cone is passing through the center line, and we have to draw this line joining this edge and this edge as a dash line. Again, we can take the projections below and complete this view as it looks like this. We have to complete these points with the dash line because it is in the cylinder. Now this is the method of you can say partition. There is a method. You can go with standard or traditional method like drawing the side view and going there. And also this is one of the advanced method where you have this particular cone. In that case, you can just have the center point and draw a semicircle and make the parts. Okay. So yesterday I told you that as many parts as you do, you get the accurate curve of intersection. So let us say we are having 1, 2, 3, 4 parts. So basically, if it would have been a circle, then it would have been 8 parts. So we have taken 4 parts of a semicircle. Now we have got these points. We have to project here like this, and we have this over here. We have got this 1, 2, 3, 4, 5 points. So 1, 2, 3, 4, 5. Now why 6, 7, 8? Because it is also to the back side. Okay. Front side we are looking at 1, 2, 3, 4, 5, 6, 7, 8 may come at the other end. That is why we are going to put this like that. Now what we have to do next, we are going to project these points to the apex point. Now this point is called the apex of the cone. Okay, we have to project this. Now we got the intersection point here. So this blue line and this green line coincides here, 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 here. So we got these points. Similarly, we can take these dimensions and complete this view in the front view. Okay, and name this as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash as usual. Okay, now we have got this point of intersection 1, 2, 3, 4, 5, 6. Project these lines and see where is one point. This is one point, it goes to here. So we have got this point number 1. where is 2 point, this is 2 point, it comes here and here it intersects, so it goes to here. Okay, so this is how this is 8 point and it goes to here. Similarly 2 will be here, 2 and 8, because they are both on same line. Similarly 3 7, it goes 3 7. Okay, this is how we have to put the points 1 2 3 4 5, 1 2 3, and complete this view as a curve. This is the curve of intersection when the cylinder is standing and cone is penetrating. Okay, now the one thing that you must observe, that it is not said that where is the apex. Now we have to imagine the apex is at the left side. If it would have been said that the apex should lie to the right side, then the complete diagram goes flipped. You have to flip the diagram. So it is your free will. You can go with both the views. Okay, so this is how we are going to draw this complete view of a cylinder penetrated by a cone. Now there is another example, square prism and square prism. This is how it looks like. A square prism, as you know, is standing and a square prism is penetrating through it. So let us see what is the given point. The given point is a square prism is having a 30 millimeter base side. So each side of this square prism is 30. So 30, 30, 30, 30, 4 times, because it is a square, and the axis or the height is 17 and is completely penetrated by another square prism of 20 mm. So 25 mm, sorry. So this is the 25 mm, 25 mm, another side which is at the back, we can't see here, which is 25, 25. So all the sides will be 25 and the height will be 70 mm, same as that of this standing prism. Now what they are saying, it is completely penetrating and bisecting. So from the center we have to take it. In case if you asked to draw the penetration at a particular height, then you have to take the height from the horizontal plane. Okay, say suppose they are saying penetration should happen at the 15 mm above the horizontal plane. So this rather going with this center point, we have to draw this penetration from the 15 mm height. And another condition is all the faces of prisms are equally inclined to VP. Draw projection showing curves of intersection. Now they are saying the vertical plane is there. Now which is the vertical plane? We draw this XY plane, which is horizontal plane, and the plane which is behind you or behind this drawing is, as you can see, this is a gray part here. This part is a vertical plane, and they are saying that all the sides are inclined to this vertical plane. Okay, so this is how the condition is given. Now let us see what happens or what we can do with it. First you have to draw the XY line. Draw the first prism. The first prism is given, which is 30 mm each side. Now why we are drawing like this? Because it is said that the lines or the sides are inclined, not horizontal. Okay, let me show you. This is one thing I have. If you can see this is a square. Okay, now this is a square. Now what they are told, horizontal and vertical plane is having inclined, these sides are having inclination. Okay, so that is why we have to draw like this. Okay, but if they would have said that it is not inclined, then we have to draw like this. Okay, So I have hope you are understanding this. Okay. Now this is how we are drawn with the top view of the square prism, which is standing one. Now point this 1, 2, 3, 4 and get the projection and complete the front view. Now if you see the front view, we got one line, two line, three line, one line, two line, three lines, okay, which are visible. Though these lines which are drawn with less thickness are not completely visible because there is a penetration. So at the first you can draw or complete the view with thick lines, then later you can just rub and include the dash line. Okay. Also name this as 1 dash, 2 dash, 3 dash and 4 dash. 1, 1, 2, 2, 3, 3, 4, 4. This is how we have to draw. Take the projection to the side view like this, 1, 3, 2 and 4. Take this to the horizontal plane and complete the side view. In side view, we can draw the complete view. And now the condition starts. This penetrating square prism has to be drawn at the center because it is bisecting. It is said that it is bisecting. That is why we are taking at the center only. So name the points first and draw the another prism with the inclined face because it is said that it is inclined. Okay, if it is not said, then we have to draw the only simple non-inclined or parallel view of the prism. Now we have got the point, we have to give the point or names to it. So A double dash, B double dash, C double dash, D double dash, because this is double dash view. Okay, so make sure that whenever you draw a top view, there will be only 1, 2, 3, 4. When you draw front view, you can go with 1 dash, 2 dash, 3 dash, 4 dash. And when you go in the side view, you go for 1 double dash, 2 double dash, 3 double dash, 4 double dash. So all the points which are given in this particular view will have double dash notation. All the points which are drawn in the front view will have single point notation, that is dash. And all the points which are drawn in the top view will not have any notation. Okay, only points have to be there. Now we have got these points. Now we have to take the projection. So take the projection from A, B and D and C. Now we know the length. Okay, draw the complete view of this particular stuff and we are going to get this point. Again, draw the projections for the top view also, and we know the projection from here or the length of this particular prism, which is also 70 mm. So complete the view like this. Okay, now we have to get the points of intersection. This is the first point which goes here. This is the second point which goes here. Now this is the point where A and C are going to intersect. So A, B and D, C. A, B and D, C. Same to the left side, same to the right side because it is a symmetric one. Okay, and complete the views like A dash, B dash, C dash, D dash. Same is here. Now complete the curves of intersection like this. So we can say this is how our prism is going to look like. Okay. Now complete the view with the help of these lines of hidden type. Okay. I hope you are understanding this. There is no confusion. Let us see which example is there. Cylinder standing and triangular prism penetrating. Now you know prism is there and it is triangular and there is a cylinder standing. First we have to draw the XY line, draw the cylinder's top view, draw the cylinder's front view, name it notations like this, take the projection, draw the side view of cylinder. This is usual method. Okay, we have got the diameter is 50, axis is 70. Okay, now it is penetrated by triangular prism of 45 mm side and 70 mm axis, and horizontally. Okay, it is penetrating horizontally. One flat face of prism is parallel to VP. Now what is said? VP is what? Whatever the XY line is there, above the XY line is VP, and below the XY line is HP. This is horizontal plane, this is vertical plane. Okay, ह्या वर्टिकल प्लेनला प्रिझमचा फेस जो आहे तो पॅरल आहे असं त्यांनी सांगितलेलं आहे. नाउ लेट अस ड्रॉ द प्रिझम. दिस इज द ट्रायंग्युलर प्रिझम. ओके, आणि दुसरी कंडिशन काय सांगितलेली आहे? इट कंटेन्स ऍक्सिस ऑफ द सिलेंडर. त्याचा जो फेस आहे तो ऍक्सिस ऑफ द सिलेंडर मधून जातोय. सो दिस इज व्हाय वी आर ड्रॉइंग लाईक दिस. Now what is the sides are given for this prism, which is 45 mm. So 45 mm चा triangle आपल्याला side view मध्ये draw करायचा आहे. We got the denotation or diagrammatical representation like this. This is how it is going to look like. Now give the points like this. Take the projection to the side view. Draw the projection. We know the length of this particular stuff, which is 70 mm. Again, draw the hidden lines and complete lines. Then take the projection. Okay, from this side, from front view, it is going to look like this. This is the side view. Okay, it is going to look like this. This is the front view. Take the projection below and draw the complete view like this. Name the points and take the projection once again like this, and we got these points of intersection, and just put the points over there and complete the curve of intersection like this, like this. Okay, so this is how the cylinder which is penetrated by a triangular prism can be seen. Okay, so this is all about our today's session. I hope you understood this, and if you have any question, you can contact me and let me